So we'll make a start. So let's say we were asked to integrate something like, I don't know, this one here. So e.g. the integral of 2x plus 8 to the power of 10 dx. Now previously what you could have done was multiplied out all 10 brackets using either binomial expansion or doing 10 brackets and multiplying them out, but that would be quite wasteful. It would take ages. You'd end up with 11 terms then to integrate. So this is possible a different way using a substitution. So what I'm going to do is try and make a substitution to make this integral look a lot simpler. So first thing I'm going to do, so step 1 will be let u equal the innermost part in the bracket. Now this isn't a hard and fast rule for substitution, this is just a few more basics. It might be a few more basic questions. It might be that you let u equal something different to what's in the bracket, but for now, as I say, not a hard and fast rule, but that's what we're going with for now to introduce you to the topic. So, what we're going to do, let u equal, in this case, 2x plus 8. Which means our integral, which I'm going to denote by I, our integral I, is equal to the integral of u to the power of 10 dx. Something that's really bothering me is I've got against my normal colour coding here, so I'm going to change that, make it red, as I normally do for notes. There we go. So our integral now is u to the 10 dx, but unfortunately we can't actually do that because we can't integrate u dx. We can't integrate u's with respect to x, they're two different letters, so we need to find some way of turning this dx into a du. Well, the way to do that, step 2, find du by dx, and rearrange to say dx equals something. So rearrange this after we've differentiated it to say dx equals, so find du by dx. So du by dx, in this case, if I differentiate this with respect to x, I get just 2. Which means that du equals 2 dx, which means that dx equals 1/2 du. Now you might see some textbooks and things write du over 2, which is a perfectly valid way of writing it, but it's quite confusing. I think of dx's, du's as being a sort of a closed bracket for an integral. So this opens the integral, and this closes the integral. So I like to have the du at the very end rather than saying du over 2, just to make it a bit more clear. So what we've got now, our integral is now I equals the integral of u to the 10. But we can do better than writing dx now. 1/2 du is what we can replace dx with, times 1/2 du. And if we rearrange this a little bit, so any constant multiples can be taken to the outside of an integral to make it a bit easier. Now we've got an integral we can do. So we'll replace the dx with what we found dx to be, ending up with an integral completely in terms of u, which has made it a lot easier. So now, half the integral of u to the 10 du. Well, step 3. Do new integral which is only in terms of u, which means that I for integral equals a half u to the 11 over 11 plus c equals 1 over 22 u to the 11 plus c. And we're almost done. The final step is conclude in terms of the original variable. Conclude in terms of the original variable. So remember, u was 2x plus 8. Our question was in terms of x, not u. So 2x plus 8. Therefore, I equals 1 over 22, 2x plus 8 to the power of 11 plus c. And this works for a lot of other formats as well. So let's take another example, a slightly more complicated format of, but only slightly more complicated format of integration by substitution. And let's see if we can apply this model, this method, to that. So there it is there, and it's already told us the substitution. But we could have deduced that, what the substitution is, because the substitution is the innermost part of the bracket, for now at least. So the innermost part is x cubed plus 2, or 2 plus x cubed as it's written here. And the question's been kind enough to give us the substitution. So let's follow those steps. So step 1 was let u equal 2 plus x cubed, which it's already told us, so we're not going to write that down. But let's now write the integral completely, as far as we can, in terms of just u. So we've got the integral of 3x squared, then the 2 plus x cubed is u squared dx. And notice we've got more terms lurking around here. There's some x's involved that might need to go. Well, in fact, this certainly will need to go, because we can't integrate x's and u's together with respect to x. So let's do the next step of finding du by dx. Find du by dx. See if you can get a step ahead of me. I'll give you 20 seconds to do that. Find du by dx, then rearrange it to say dx equals. Right, so du by dx equals, we can see here it's 3x squared, which means that du equals 3x squared dx, which means that dx equals 1 over 3x squared du. And this is where some of the magic happens, because now if we try to write out the entire integral in terms of just u, I get 3x squared, u squared, but instead of dx now, I've got the right to replace it with something I know is equivalent, 1 over 3x squared du. And notice that when I simplify this, the 3x squared on the top and the bottom disappear. 3x squared over 3x squared is 1. So actually it's turned into a much nicer integral. The integral of u squared du equals u cubed over 3 plus c. And then remember what u was. It was 2 plus x cubed. 2 plus x cubed squared cubed rather, over 3 plus c. And there's our answer. Let's do another. I'll give you a moment to think about this one. And again, it's told us the substitution. The innermost part, and the most tightly wrapped part of that is the x squared. That's the innermost part. So follow the steps. The integral of 2x e to the power of u dx, because we let u equal x squared, we'll replace that x squared with a u. So the next step is to try and get rid of all the x's altogether, and we'll start with this. Du by dx equals 2x. Rearrange that to say dx equals. See if you can get a step ahead. So du equals 2x dx, which means that dx equals 1 over 2x du. So now we can write out the integral again, the integral of 2x e to the u, but instead of dx, 1 over 2x du. And notice 2x over 2x is 1, so we might as well not do that sum at all, it cancels. Equals the integral of e to the u du, and we know e to the u integrates to itself. Which is just e to the u plus c. So a justification of e to the u integrating to itself, by the way, we know that e to the x differentiates to itself. If we differentiate it, we get e to the x. So we work backwards. The same thing must happen. E to the u plus c equals e to the x squared plus c. Remember, u was x squared. So another fact that I'm going to tell you before we'll go any further, if we differentiate ln x we get 1 over x. So we learned that in the differentiation section. So if we integrate 1 over x, we should get back to ln x. But that's not 100% true. It doesn't exactly, in this case, work properly in reverse. Actually, the fact that I want you to learn is that the integral of 1 over x dx equals natural log of modulus of x plus c. the modulus is very important. So let's do an example in which this becomes useful. So let's try this one here. Any questions, just type them in the chat. But take a moment, see if you can try this one yourself. Okay, so let's write this just in terms of u as far as possible. So the integral of 3x over u dx. Let's try and replace that dx with a du now. So we do that by finding du by dx is 2x, which means that du equals 2x dx, which means that dx equals 1 over 2x du. So if we write that integral out and try and simplify it a step further, integral of 3x over u, and now instead of dx we're going to write something equivalent, 1 over 2x du. And notice that we've got x divided by x, which is 1, so they cancel. And remember what I said before about constant multiples being able to be taken outside of the integral sign. So what I could do is this here, 3 over 2u du, but I don't think that's very helpful. I think it's much easier if we take the constant on the top, 3, and the constant on the bottom, 2, outside of that, to leave just a u on the bottom, like that. And now that we've got that, this is very much like this here. See if you can conclude with an answer. Take 30 seconds, then I'll write my answer. Equals 3 over 2 log modulus of u plus c equals 3 over 2 log modulus, and u was x squared minus 2 plus c is the answer. Let's do what that involves trigonometry. So in this one, u is sine x, so it's the integral of u to the power of 4 cos x dx. And then we have du by dx equals cos x, because the differential of sine x is cos x. That means that du equals cos x dx, which means that dx equals 1 over cos x du. Then that leads us on to actually write this out purely in terms of u. So the integral of u to the 4 cos x times 1 over cos x dx. And notice cos x divided by cos x is 1, so they cancel, equals the integral of u to the power of 4 du, and that there should say du, equals u to the 5 over 5 plus c. And remembering what u was sine x to the power of 5 over 5 plus c. And whilst I hate the notation, it's standard notation, so I should probably write it back in the normal way that you would write sine x to the power of 5. Although what I'd written here would be worth full marks, but might as well keep with convention. There we go. So before we move on to integration by substitution with limits, let's have a look at one more that involves a square root sign. So see if you can have a go at that one there. Take a couple of minutes to get a head start, then I'll have a go. First thing, the integral of x square root of u dx. However, we know when we're integrating it's unhelpful to have square root signs, so we should rewrite it as a power like that. So we now have du by dx equals, in this case, minus 2x. 1 minus x squared differentiates to minus 2x, which means that du equals minus 2x dx, which means that dx equals minus 1 over 2x du. So now writing it out completely in terms of u, it's integral of x u to the half, and instead of dx we'll write times minus 1 over 2x du. And notice that that x there and the x there cancel. X divided by x is just 1, so we can tidy that up a little bit. So minus 1 over 2 u to the power of a half du. And if you want, as I said before, multiple constants we can take outside to make the integral a little bit easier. So minus a half integral of, and it's debatable whether you think this does make it easier or not. I personally think it does, but you might not, in which case it's fine, don't do it. Equals, so add 1 to the power, becomes u to the 3 over 2. Divide by the new power, divide by 3 over 2, and dividing by 3 over 2 is the same as timesing by 2/3. plus c. Tidying that up a bit, I can see that this 2 here divides by that 2 there to make 1. So I end up with minus 1/3 u to the 3/2 plus c equals minus 1/3, and u in this case was 1 minus x squared to the 3/2 plus c. So that's that. So now let's move on to one that has limits. And the steps are pretty much the same, apart from a couple of small differences that don't really make the question that much more difficult. So let's try this one here, and I'll guide you through this first one. So the main difference is there's two limits, 2 and 1. So let's go through the process of trying to integrate. So our substitution is going to be the innermost part of the bracket. So in this case, let u equal x squared minus 3. And if you want, we can get the du by dx bit out of the way now. Du by dx equals 2x, which means that du equals 2x dx, which means that dx equals 1 over 2x du. And if you want to do it as a bit of a sideshow here, that's absolutely fine. It needn't form the main body of your answer, just as long as it's clear how you've got what dx is equal to. So now let's try and write this completely in terms of u. So we've got x at the front, then the x squared minus 3 was our u, so u cubed. And instead of dx, I'm going to write 1 over 2x du. And notice that these x's cancel. Now there's one hidden mistake in this, because this function here was in terms of x. So these limits were x values. So you know what to do with limits on integrals. Sub the 2 in, sub the 1 in, subtract the 2 of them. But now we've transformed this function to be just in terms of u. These limits no longer apply. Those were x limits, but now we're talking about everything in terms of u. We need to make u limits. So to get the u limits, we know the x value. The x values were 2 and 1. We sub them into our u formula here. So u limits. So x equals, and let's put the upper limit in first, x equals 2 implies that u equals 2 squared minus 3, which is 1. And x equals 1, which means that u equals 1 squared minus 3, which is minus 2. So our new limits in terms of u are now 1 and minus 2. So that's a key point there. Remember the u limits. So that's there and that's there. U limits are very, very important. So let's simplify it now. So the integral between 1 and minus 2 of u cubed over 2 du, and then we're ready just to integrate, equals, so add 1 to the power, u to the 4, divide by the new power, puts 8 on the denominator, and because we've got limits we don't need to worry about the plus c. And good exam technique when doing integration by substitutions and subbing in limits is to show the limits actually being subbed in as well. Because in the event of a wrong answer, doing what I've done here is worth a mark, actually physically subbing the limits in, showing that you can use the limits. Like that. And just in the calculator now, so we've got 1/8 take away, and that one is, so 2, well, I'll not do, actually I was going to do a bit of it in my head there, but actually I think that's bad practice, because when exam nerves and things kick in, people can make daft mistakes. So -1 and 7/8. I'm just going to change my calculator from that horrible display fraction result, and I want it to be, there we go, I'll press equals again, there we go, -15/8. And we can check that on the calculator. We can put our original integral in the calculator just to check that it works. So the integral of x squared minus 3 cubed, bottom limit 1, upper limit 2, and hopefully it's going to give me the same answer. Yep, -15/8, there it is. So let's try another. There we go. So the integral between 3 and 0 of 4x over x squared plus 1. Now choose your substitution carefully. Have a go at that. As I say, as I normally do, I'll give you a couple of minutes to get started, then I'll take over. In this case, I'm going to let u equal x squared plus 1, which means that du by dx is 2x, which means that du equals 2x dx, which means that dx equals 1 over 2x du. And we know we're going to have to put u limits in there as well. So let's do that now as well. U limits. So the upper limit is 3, which means that I can get a corresponding u limit by subbing into this formula for u. U equals 3 squared plus 1, which is 10. X equals 0, which implies u equals 0 squared plus 1, which is 1. So we've got all the ingredients we need now to be able to do this integration. So it becomes the integral between not 3 and 0 anymore, but 10 and 1 of 4x over what we said u was, and dx we know to be 1 over 2x du, like that. And we know the x's cancel to make 1, and 4 over 2 puts a 2 on top as well. So I don't want to start crossing numbers out and rewriting, because then it'll just get messy. I'll just make the next step the natural process in the cancellation. So 4 over 2 is 2 over u du. But again, remember, constants can be taken outside of the integral. So as long as it's a multiple constant, i.e. multiple of 2 in this case, to make this look a bit easier, I just think it's nicer to write it like that, because then you've got the integral of 1 over u, which you know is log mod of u. No plus c though. And the reason for no plus c is because we've got limits. Equals 2 lots of log 10 take log 1, and we know that log 1 is 0, equals 2 log 10. Now what we can do to check our answer, put the original in the calculator again. So the integral of 4x over x squared plus 1 between 0 and 3, but it's not going to give a nice answer. It's going to give that. But what we can do, if we subtract the answer we got, if those two answers are truly equal, then we should get 0. Now, what's happened here, we can see that the calculator has done a little bit of an approximation in working that out. See how close this is to 0, so that's just a rounding error in the calculator. So this is so close to 0 that it essentially is 0, therefore our answer still holds. So this is just a rounding error that the calculator made in its method for calculating the area. We'll try another before we move on to a couple of different types that I feel you should see. So have a go at this one here. Now this one's been kind enough to tell us the substitution, although you probably would have deduced that yourself. Have a go at that one. Remember, e to the x differentiates to itself times the differential of the power. So I did a couple of steps in one there. rearrange it to say dx equals. And then find the u limits. Like that. And notice that e to the 2x's, e to the 2x over e to the 2x is 1, so that disappears. Just write it out more neatly each time. So that becomes u to the 4 divided by 4, which makes the denominator 8. Between those two limits, equals, so sub in the upper limit, 1 plus e squared to the power of 4 over 8, take 2 to the 4 over 8. There's not really a better way we can write that. I would argue it doesn't make it simpler to multiply it out. So 16 over 8 is 2. I think that's the way we should leave it. So now let's have a look at a different type. We're going back to one without limits again. There's just a couple of minor complications that can be thrown your way in these questions. So this one here, just a couple of strange things that could happen. So 1 second, it's glitching a little bit. Let's try it this way. So there we've got that there. And it's again been kind enough to tell us the substitution. The u equals 2x take 1. So let's do the du by dx part straight away. Get that out of the way. Which means that du by dx equals 2. Do a couple of steps at once. That means that dx equals a half du. No limits to worry about here, so we don't need to do any more changes. So let's just start writing this out now. So we've got the integral of x, then u to the power of 4, and instead of dx we can write a half du. And here's where the issue lies, because up until now all the x is cancelled. This one, there's still a rogue x lurking around there. We can't integrate until that x becomes u. So nothing's going to cancel, so it looks like we're stuck with it. However, there's a neat little trick we can perform. We've got a formula here relating u's and x's. So if we rearrange this to say x equals, that makes the x disappear. So we've got u equals 2x minus 1, which means that u plus 1 equals 2x, which means that x is actually u over 2 plus a half. Now I've purposely written that as two separate terms rather than u plus 1 all over 2, because we're going to have to multiply out some brackets later and it's easier to have it like that. Okay, so that's equal to the integral. Instead of x now, we're going to write u over 2 plus 1 half. Then there's u to the 4. And that half there we'll take to the outside. Du equals, and we can take out another factor of a half actually to make things even easier looking. So we'll take a half from that bracket and put it outside. That then becomes a quarter. The integral of u plus 1 times u to the 4 du. This is quite an easy integral. This is one of the ones that you'd, from this point onward, is the sort of one you'd been given when you first started learning integration. Equals a quarter. We just multiply out the bracket. U to the power of 5 plus u to the power of 4 du equals a quarter u to the 6 over 6 plus u to the 5 over 5 plus c equals a quarter of, then u we let equal 2x minus 1, so the substitution was 2x minus 1 to the 6 over 6 plus 2x minus 1 to the 5 over 5 plus c. And there's no benefit to factorising that, even though the solutions in the questions that I've put online for you do actually factorise it. There is no need. So let's have a look at one involving trig. Let's have a look at this one here. This time it's different again, because it's not let u equal something, it's let x equal something. And this is one of the ones I was talking about before. When I first started, I said it's not a hard and fast rule that you let u equal the thing in the bracket, because if that were the case, we'd let u equal 1 minus x squared here. You can try it yourself, but that's not going to work. That's not going to make it any simpler, letting u equals 1 minus x squared. And typically in questions like this, they'll suggest a substitution. And I say typically because there's been one case in a specimen paper where I've seen they haven't given you the substitution. They've guided you and said use a trigonometric substitution, but they've not given you the exact one. So here they've told us to let x equal sine u. So let's see how this plays out. So we've got the integral, and I'm going to leave the limits off for now because I know that I'm going to have to change them in a second. The integral of 1 over the square root, and x equals u, so that becomes 1 minus sine squared u dx. So if we do the differentiation now, but it says x equals, so we're not going to find du by dx. In this case, because it says x equals, it'll have to be dx by du that I find. So dx by du is the differential of sine u, which is cos u. Which means that dx equals cos u du. So let's go back. and write this purely in terms of u now, equals the integral of 1 over square root of 1 minus sine squared u. And instead of dx, we're going to write cos u du. And now's when our trig identities come in. This all depends on you knowing your trig identities. So here, 1 minus sine squared u, you hopefully can identify is cos squared u. So that becomes the integral of, and on the top we've got cos u, on the bottom we've got the square root of cos squared u du. And the square root of the something squared is just that thing, equals the integral of cos u over cos u du. This has become very, very simple now, because it just becomes, via this neat little substitution, the integral of 1 du. And it probably helps now to find out what the u limits are. And this integration only works, by the way, in radians. So when x equals a half, so let's do the u limits here. U limits. So x equals 1/2. So that means that sine u equals 1/2. Which means that sine u equals 1/2. Which means that u equals the inverse sine, arc sine, of 1/2. So the arc sine of 1/2, which is a 6th pi. And the other limit is 0, x equals 0, which implies that sine u equals 0, which means that u equals arc sine of 0, which is also 0. So now the integral 1 du is u. Between the two limits, pi over 6 and 0, which equals pi over 6, sub that in, and always write the minus 0. Even if this here says 0, right, take 0. Otherwise you could lose marks for not subbing in limits properly, which is equal to pi over 6. And there's loads of those on the worksheet that I've put in the lesson area, the integration by substitution worksheet. So have a go at those. And yeah, that's it. That's the introduction to integration by substitution. So hope you found that useful.